So, hello Las Vegas. I work in AWS's Vancouver office, which is a pretty big office and where a lot of the event-driven software gets built. And at least half of my own engineering time goes into event-driven stuff, and that's the agenda for today. And I'm going to be pretty happy, and it's mostly going to be in good news. But let's bear in mind that this whole modern cloud-native event-driven stuff is pretty new space, and we haven't established all the best practices yet. So we're not ready to declare victory on all fronts, and I'm going to end with a little walkthrough of some still unsolved problems, so I won't be waving the victory flag the whole time. So we're going to have to do a little bit of diving into abstractions, but to avoid having too much of that, let's start with a survey of a working example of a very successful event-driven application, just to make all this stuff concrete. And the example I want to use is this website we run named after a river in Brazil. And I'm going to guess that one or two of you have been there once or twice. And of course, the main objective of that website is to get you to press that buy button. And then once you've pressed the buy button, then we have to do a bunch of stuff that involves, getting stuff off of shelves and putting it in boxes and putting boxes on trucks and so on. And of course, that stuff all happens in a place that looks like this. And the process is, so when you click buy, we have to check your credit card to make sure you can pay. And that takes about a millisecond or two. And then this doesn't. That doesn't take milliseconds at all. That stuff takes, minutes, hours, days sometimes. So anybody can see that you clearly couldn't have a synchronous API call from the website to Amazon's back end saying, please, assemble and pack and ship and box and fill and come back to me when you're ready. That would be insane. So what the front end does when you click that buy button after having validated the payment, it puts together a small package of information describing the event that somebody bought something, and it'll put your account number and the credit card confirmation number and what you bought and where it's being shipped to and all that stuff in a package of event and drop it into the cloud. And then at some subsequent point, another piece of software will pull it off and start the packing and shipping and trucking and all that stuff. And the key point about this process is that these things can run at different rates. Now, normally, on an ordinary weekday or whatever, the rate at which people are clicking buy and the rate at which boxes are going out the doors are, roughly equivalent, and everything's humming along smoothly. But on days like Friday of last week and Monday of this week, you can bet that people were hitting that buy button immensely, immensely, immensely faster than the warehouses could operate and do their jobs. And that's okay. I have actually seen live production queues at work that have 1 billion messages on them. And that's okay, because the back end, after everybody's gone to bed and so on, will work its way through and pick the stuff up and run it. So this is a clear event-driven architecture, and this is the right way to build Amazon.com. Any other way of building Amazon.com would be the wrong way. So let's look at what we had to do and what we needed from our event-driven infrastructure for this to work. So first thing we did, we need, obviously, is scalable ingestion. Once we've created the purchase event, we need to be sure that we can drop it into the infrastructure really fast and probably not get throttled, and it can scale to however fast we're running. And we really, really care a lot that once the order event is out there, that it not get lost. It has to be stored very durably because, that's our bread and butter, obviously. Another thing we need is that we need these events to be processed by more than one party. It's not just the warehouse with the boxes and trucks. Accounting has to get it. Tax has to get it. Compliance has to get it. Marketing has to get it. Probably 4 other departments that I don't even know exist have to get this to do their jobs. So fan out is basic. On the other hand, we don't care if things come out in exactly the same order. If you clicked buy 3 seconds before I did, but my order gets to the warehouse first, who cares? We don't care that much about deduplication, which can happen in network systems. If some order event by some accident gets duplicated and shows up twice, our back-end systems use transactional systems such that they can successfully detect a duplicate and just throw it away without any trouble. We do not need push delivery. We do not need to take these events and push them into the warehouse software. In fact, the warehouse people really don't want us to do that. because they don't want to get events at a rate faster than they can process them, so they want to pull them out of the eventing infrastructure. And finally, latency. It takes a few seconds to get there. Nobody's going to lose any sleep. So why did I walk through all this? Because let me put it this way. Are these requirements and non-requirements the same for every event-driven application? Well, obviously not. But these kinds of questions that you have to ask about any event-driven application come up all the time. So I'm going to spend quite a bit of my talk today talking about facets of event-driven software, such as these, and what they all are and how you think about them, because some combination of them is going to describe your situation and maybe give you some help in picking the right eventing infrastructure. So before we get into the details of eventing facets, let's ask ourselves an important question, which is, should you be looking at event-driven software? Is it the right thing for you? So that's a complicated decision, and sometimes you don't have any choice one way or the other. But here, I wanted to just run through a few what I consider to be really strong indicators. And if these things are true, that means that, yeah, you should probably seriously be looking at event-driven software. So the first one is, well, like we have at Amazon.com. If you look inside at the contents of an event, that is quite strongly unrelated to any event before it or after it. Each of them are sort of self-describing and standalone. And that means you can code your back-end software in a mostly stateless way, because these things are self-describing and have everything you need to know. And I just cannot emphasize enough, if you're building large server-side applications, the extent to which you can be stateless is great. Not having to keep a persistent state of what's going on out in the world. Now, there are a lot of applications that are not stateless because they can't be. There's just some business requirement that prevents it. There's also some applications that are not stateless but could have been. They just didn't think about it. So think about it. And one of the nice things about being event-driven is it generally makes it easier to build stateless backends. But anyhow, if your data looks like that, you probably want to use events. Next thing is, sometimes you sort of have to use events because that's where the data is. So this little screenshot here is from S3, wiring up an S3 bucket so that every time an object gets put into it, it'll fire an event, which in this case we're routing to a Lambda function. And there's actually more and more of this around AWS and sort of the internet in general, not just us, where there are various things that will issue asynchronous events when certain things happen. And if you have this, go with the flow. Don't try to dodge it. Just build an event-driven application because that's what the infrastructure is wanting you to do. By the way, this one here in particular is super popular. I don't know what percentage of S3 buckets are now wired up to do this, but the proportion goes up and up and up every year. Once you've written the first one of these, it's really addictive. You just write Lambda functions or whatever that respond when it happens, and it's really pretty easy. Another thing is, how strong do you need to have your microservices decoupled? More or less 100% of large-scale modern applications consist of multiple microservices that talk to each other. And you would probably like to have sort of a strong, asynchronous, buffered, robust interface between them, because if one of them suddenly gets a surge of traffic, or conversely, one of them runs into some sort of an issue and starts to slow down, you really can't afford for them to be temporally wired to each other, so they all have to speed up and slow down at the same time. So, the slide I should have talked about was, this is a slide from my talk last year when I talked about how SQS worked, and it's an example of this scenario where you have microservices that need to be strongly decoupled. Now, an interesting point is, sometimes the need for strong decoupling may not be technology-based, it may be organizationally based. Perhaps the two of your microservices are being written by different teams, in different programming languages, in different offices, in different departments, maybe these days in different companies. And all of these circumstances greatly increase the value of having really strong, clean decoupling between your microservices. And eventing is the way to get that, probably the best one. The final criterion that screams event-driven is publish and subscribe. Publish and subscribe is a very popular pattern for shipping messages and events around. I'm going to talk about it some more later, but it is got events written all over it. If you're publishing and subscribing, you're probably already doing event-driven, whether you know it or not. So I'm not going to claim that's an exhaustive list of all the good reasons to be event-driven, but I think they're all pretty strong ones. So now I'm going to ask a hard question, which is, what does this word event mean anyhow? We use it a lot. I'm going to use it really a lot over the next hour. And what are we talking about when we talk about events? So we can all agree that when they're on the wire or being stored, they are made up of a moderate number of bytes of data. But what are they? What do they mean? Good question. But let's push that on the stack and let's actually look at some real concrete examples of events before we try and get all existential here. So here's an example of an event that you might get that tells you about a state change in an EC2 instance. And I should remark that there are a lot of things on AWS and around the internet that can reasonably be classified as events. For the examples I'm going to show now, I'm going to talk about a very specific category, which are the events on our EventBridge service. AWS events, we'll call them. Anyhow, this is an example of one of those. It tells you about a state change in an EC2 instance. So let's walk through that from the bottom up. At the bottom, there's a field called detail that contains the service-specific details about the payload, really, of the event. And it's a very simple, minimal payload here. Here's the instance ID that changed state, and there's its new state. Now, at the top level, there's a bunch of other fields, 8 in total, and I think they're pretty well all self-explanatory, except for perhaps the detail type field, which works sort of like the content type in HTML. It tells you what the payload is. To be precise, the combination of the source field and the detail type field tell you what this is. In this case, this is from EC2, and it's an instant state change notification. And by the way, keep this simple little event in mind because I'm actually going to use it a couple more times to illustrate one thing or another. We generally refer to these fixed top-level fields as the event envelope. And whereas there are lots of things that are events but that aren't AWS events, but anything that has an event envelope is an AWS event, and it's actually helpful in processing it, having a set of standard fields at the top level where you can work with them. So here's another example of an event, and this is an AWS event, but it's not from AWS. It's from Zendesk. You can tell that by looking at the source. So once events are running through the system, they all have a source field, and only we are allowed to have source fields that begin with AWS dot. So you can see things like AWS.EC2 and .S3 and so on and so forth. But in this particular case, we have a special API that partners of ours can use to inject events for their customers. And so in this case, the source is AWS.partner/Zendesk, and this is a ticket status changed or something like that event. It's too big to fit on a single slide. Last time I looked, the average size of messages on EventBridge is 1K-ish. So two things that are worth saying about this whole subject. The service EventBridge should probably just have been named AWS Events, and that would be a good idea, except for it would be a bad idea because anybody who is trying to find it would instantly be in Google hell. Because if you type AWS Events into Google, what do you find? reInvent and summits and things like that. So we couldn't do that, so it's called EventBridge, which I guess is not terrible. Second, this notion of having an event with a sort of a standardized envelope, fixed top-level fields, is useful, and it crops up all over the place. So it turns out there's an industry group called the Cloud Native Computing Foundation, CNCF, which is an outgrowth of the Linux Foundation, that has been working on standardizing it, and they took what they call cloud events to release 1.0 just a month or two ago. And here is an example of a cloud event. And this is taken from their repo over on GitHub. There's nothing at all wrong with their design, and I suspect that if it had existed when we started doing our events, we would have probably used it. But one of the things you learn when you're writing eventing software is that after you've started shipping events out into the ecosystem, it is very, very, very difficult indeed to change anything in them. Where by difficult, I mean impossible. So this cloud event is perfectly reasonable, but it's kind of boring because it doesn't have any real data in it. So let's put some real data in it. But let's not do it by hand. So what I've done here is written a little small Go function that reads any AWS event and transmogrifies it into a CloudWatch cloud event in JSON using our AWS Event SDK and a snapshot of the Golang SDK for cloud events. And it's not really very challenging. And what I'm going to do, I'm going to wire this up so you can run it as a Lambda function, probably as a layer, and I'll open source it. But I'm not doing that yet because neither of the libraries had reached 1.0 and been frozen when I wrote it. So I will when that happens. And of course, here's what you get. So here is the EC2 instance state change notification event wrapped up as a cloud event. And the point I'm making is that the impedance mismatch is very, very low. And if you need to use both, just don't worry about it, because it's dead easy to convert them back and forth. OK, so now we've looked at some very, very concrete events with the actual quotation marks and JSON syntax. And let's return to the larger question of, well, what do events mean? What are they? One of my closest coworkers, the general manager who runs Eventbridge, is a really smart person. And they were the inventor of the idea that became Eventbridge. And they love to talk all the time about what events mean. An event can be a command. Subtract $387 from this bank account. It can be just a fact. This EC2 instance state changed. It can be a record of something that somebody did. User 32R3 changed bucket 567 to have world readable protection. Oops. It can be something like, oh, of course, like Tim Bray just bought an Instapot from Amazon.com. Ship it to them. So speaking as a person who spends a lot of time working with events, I find myself almost completely unable to care about that. What they mean. Because you know what? The software doesn't know what that means, what it really is. I care a lot about what you can do in terms of filtering and routing and storing and processing and reformatting and so on. And we'll talk about that a lot. But if you wanted to talk about what events mean, sorry, you'll have to go to a different talk. So now I am going to shift gears and just run through a bunch of the characteristics of event-driven software infrastructure, which I'll call facets, with the idea being that we can help structure our decisions about what kind of event-driven infrastructure is right for you. So let's just dive right in here. And the first one is, are events strictly ordered? Do they come out of the cloud in the same order they went in? Now, if you recall the story I just told about Amazon.com, well, those orders, we don't care if they come out slightly different. On the other hand, that other example I gave about deducting money from a bank account, you care really a lot. They all absolutely have to be in order. So the usual jargon we use is FIFO, for first in, first out, for eventing systems. Now, strict FIFO is only really meaningful when you have a single sender and a single receiver, because otherwise you can't even detect it. Now, you can apply FIFO at a large scale, but the typical application for that would be when you have a large website with hundreds of thousands of sessions and a huge click stream coming off it. And if you're processing that stuff, you want the events from each individual user's session to be strongly ordered. But there's no notion of global ordering across the big stream. So given that the strict FIFO-ness is only really one sender, these things don't tend to be too fast. Even 100 per second would be surprising on a FIFO stream. So some of the event-driven infrastructure offers FIFO and some doesn't. You will observe that the stuff that offers FIFO will in general be more expensive and less scalable, because that's just the laws of physics at work there. FIFO is certainly available, but it's not free. It's not even that cheap, to be honest. A sort of a related subject that comes up when you're talking about this is duplication. When an event goes into the cloud, does it come out exactly once or more than once? So this can happen in a lot of different ways. Maybe the most obvious one is that if your software that's pulling the cloud saying, give me an event, suppose you crash. Suppose the host you're on crashes. Suppose you have a nasty GC pause and lock up for 45 seconds. Eventually, the infrastructure is going to say, nah, they didn't get that, sorry, and they'll send it again, so you'll see it again. But sometimes it's our fault too. Sometimes we'll have like a data center power loss or a network partition or something like that. And we work really, really hard to never lose an event. But a compromise that leads to is sometimes you get it twice. And the jargon we use for that is at least once reception. Now, how are you going to deal with that? So a couple of ways to deal with that. So in the Amazon.com example, the back-end systems all have transactional databases, and they can detect the condition that they've received a duplicate and just ignore it. An even better way to deal with it is to make your APIs idempotent, which means you can call them as many times as you want, and nothing bad will happen. A completely trivial example of an idempotent API, just to make this concrete, would be the SQS create queue API. You can call it 30 times in a row, and if the queue already exists, it just says, yeah, OK, whatever, no problem. So idempotency is really great. So once again, there are services, SQS FIFO again, being an example, that do guarantee exactly once delivery. Well, except for if you go read the computer science theory, there's lots of very strong mathematics which purports to prove that exactly once is impossible in the presence of networks and so on. And the math is correct, but it turns out if you shrink your time windows and impose some other conditions and so on, you can get enough exactly onceness out to be useful. Having said that, just as with FIFO, you're going to pay more and get less scalability if you want exactly once delivery. Facts of life. OK. What else? Oh, this one's super interesting. Let's do it by example. In the case of SQS, when you receive a message, you receive it, you process it, you delete it. While you're doing those things, nobody else can see it. So if you think about it, if you have a bunch of readers on a queue, they're all going to see a different subset of the messages, which, for example, in that warehouse system I was talking about, is exactly what you want. You have a bunch of different parallel streams, putting boxes in trucks, and so on. On the other hand, if you use SNS, or actually streaming services like Kafka or Kinesis, the typical scenario is you broadcast an event, and then everybody gets to see it, which is called publish, subscribe, pub sub for short, and actually turns out to be sort of the default behavior we have come to expect in event-driven software. Next things. So how do you actually get the events? There's really only two ways. Either you poll the infrastructure for them, or the infrastructure pushes you at them. Once again, SQS, you want events, you have to pull them. SNS, you push events onto a topic, you subscribe queues to the topic or Lambda functions or HTTP endpoints, and SNS pushes them. So if you're looking at this thing and you're thinking, well, which of these would I like to have? You might think, oh, I'd like to have them pushed to me because that's easier. And in a lot of cases, that's true, and that's fine. And by the way, I should make a meta point. All these slides I'm showing you, neither side is wrong. These are just choices you have to make, and they make sense. So push sounds desirable, but I have to say that if you talk to a bunch of grizzled old cloud engineers like me, they get all nervous about push notification. Because if you say, by the way, please push events to me, you're kind of making a promise to be able to process them as fast as we send them, and having an endpoint that's up there and responsive all the time. And if you're talking to the AWS cloud, that can be a very dangerous place to be, because if some overeager intern writes a system load test that suddenly starts generating 200,000 per second, which you can do that, your push system is probably going to it's not going to be good. So older, more conservative engineers tend to really like polling because it has the wonderful characteristic that you only take something to process when you have the capacity to process it. What else? Latency. People care a lot about latency in event-driven systems, which gives me a chance to reuse one of my favorite slides. I've been using it for 2 years, and I don't see any reason to stop. So I occasionally have this very unfortunate conversation where somebody comes up to me and says, well, I got a hard requirement for 120 millisecond latency. Got to have that, or I can't use your stuff. And I smile and look blank, because that's just really not the right question to ask. The average latency is not a terribly interesting subject. When we talk about this stuff in the cloud, we never talk about latency without putting a P number in front of it. So P50 means the time such that the latency of half the events is less than that. P90 such that 90% is less. P99 and P100 would be all the latencies are less than that. These are typically measured over a time window, like 5 seconds or 5 minutes or a minute or something like that. So here's a graph of a real latencies coming off an AWS service, and by looking at it, you can see that half the events arrived in like a quarter of a second, 90% within a second, 99% within 4.5 seconds, and there were a few out there in the over 20-second territory. This is a very realistic graph. This is the kind of thing you see. So when you go to talk to your infrastructure provider, you don't just give them one number. You can say, OK, I need the average to be like 100 milliseconds, but I can tolerate that getting up to 15 seconds, 1 out of every 1,000 messages, or something like that. That's a perfectly reasonable thing to say. And then you can go and run some experiments and profile it and find out if that works for you. OK, what's next? All right, so there's basically two kinds of eventing and messaging infrastructure. One kind, so most of the stuff that we have built at AWS tends to be serverless and based on HTTP because it's Amazon Web Services, right? But a lot of the stuff that's out there in the industry is based on brokers, which is software that you actually run a dedicated machine and the broker's on it, and you connect to the broker and send and receive messages and events that way. And they're really different approaches, along with the ones on the slide here, which are open source. There's commercial ones like IBM MQ, and Tibco has one, and Oracle has one, and so on and so forth. Having brokers has both advantages and disadvantages. Let's look at the minuses first. The most important thing wrong with brokers is they're actual computers. You actually have to own and manage and patch and monitor and alarm and get paged at 3 o'clock in the morning about, and so on. But sometimes you need that. The other big disadvantage is that they have sort of a flat-top scaling curve. If you've got one of these brokers and that instance is running at 100% CPU, well, you're just not going to be sending any more messages through that. There are some situations where you can have networks of brokers and increase the throughput somewhat, but it's still pretty flat-topped. On the other hand, if you look at something like SQS, you can run at 10 transactions per second and then turn it up to 100,000 transactions per second within a few seconds, and that all just works. Having said that, a really big EC2 instance can put through a frightening number of transactions per second with a modern broker, so maybe you just don't care about that ultimate scaling. But these brokers also have a big advantage is they typically don't use HTTP. The way they work is you have a nailed-up TCP/IP connection, and you just send the messages in. They go straight into memory. They go out the other side. They use framing protocols like AMQP and MQTT and STOMP and OpenWire and so on and so forth. And so they can, in principle, have way lower latency. However, this is a moving picture. The reason they have lower latency is because with HTTP, you have to set up a connection and tear it down. But you know what? Maybe you don't anymore, because to start with, there's HTTP long polling, which can reduce latency. And HTTP2 is now starting to be pretty ubiquitous. And it has a single connection that you can do multiple transactions interleaved on it, also reducing your latency profile. And then what's coming over the horizon is QUIC, Q-U-I-C, probably going to be rebranded as HTTP3. And the U in that stands for UDP. So there's no permanent session at all. And once again, you're going to get a totally different latency profile, which I haven't seen the experiments, but I assume it's going to be way lower. So this is a tough choice to make, this broker versus service, because the ground is moving underneath you. Now, in a lot of cases, people don't have choices. They're using a particular JMS library that talks a particular version of AMQP, so they just have to use something. And I don't want to sound boring, but once again, these are all pretty good choices, all the way through here. It just depends on your needs. OK. All right, so here's something that may feel like a minor feature, but it seems to be making a big difference. And this is the notion of filtering. And increasingly, so in a basic pub sub system, you subscribe to an event stream, you're going to get all the events. And we have seen people writing a whole lot of really stupid code where they get every event, and first of all, they do a bunch of computation to say, do I care about that event? And then they end up throwing 90% of the events on the floor, which feels wasteful and stupid. So increasingly, the pub sub APIs and the eventing APIs come with filters, such as this one. So this one says, of all those orders going through, I only want to see things from Vitamix and Instapot, and I want the product detail field to have a subfield called price_USD, whose value is less than 150. And so that declaratively would probably filter out a huge number of events in the stream. The reason this has really been getting my attention is we introduced this feature in SNS a couple years ago now, where when you make a subscription, you can attach a filter to the subscription. And the uptake of that has been really surprising to me. An increasingly high proportion of all subscriptions now have filters on them. And I'm starting to come to the opinion that filters are sort of like table stakes. You really need filtering capability in good event-driven infrastructure. OK, next thing I want to talk about is how you actually wrap up the data. You know, do you use JSON or do you use a binary format? I got all excited about this and wrote a 3,000-word blog piece on it a couple of months ago called Bits on the Wire, if you want to really dive deep on this. At the end of the day, an event is just a blob of bytes passing around the network, and a whole lot of those blobs are in JSON. The main reason for that is that everything is RESTful these days, and most REST APIs are in JSON, so people just get the idea that, you know, stuff going over the wire is going to be in JSON. But on the other hand, particularly out there in the world of Kafka, there's a lot of people starting to, in the world of gRPC, there's a lot of people starting to use binary formats like Avro and Thrift and Ion and what am I thinking of? Protobufs, of course, and so on, starting to see a lot of that. These things, of course, you can't even unpack the bits on the wire unless you have the schema, so they're strongly typed by definition, which means they tend to be particularly well-liked by people who are living in strongly typed programming languages like Go or Java or C#. There's also this widely held belief that the binary formats must be more compact and faster because they're binary, right? And everybody knows that binary is faster. If you go look around at the benchmarks, the support for that is weak and mixed. It depends. It depends on whether the data is mostly numbers or mostly strings or mostly enums. It depends how big it is. It depends how fast they're coming. It depends on a whole lot of stuff. And the only sensible and mature thing to do if you're worried about, you know, the actual event wrapping formats, the only sensible thing to do is to go and do an experiment with your data in your message patterns. And what you will usually find when you do that experiment is that it doesn't matter at all. That, in fact, most applications are not bottlenecked on their message packing and unpacking. They're usually bottlenecked on their database or their, you know, their matrix inversions or their blockchain mining or whatever. And at the end of the day, JSON has some virtues. You know, it's kind of old these days, but it's pretty flexible, and it's really easy to deal with in dynamically typed languages like JavaScript and Python and Ruby. And you know, you can usually get away with adding a new field without breaking anything, and you can read it. You can look at it through a human eye. And so when your event-driven system has a bug, you know, we can look and see which event it was that caused the bug and what was in it. And I think that's a big deal, actually. But you know, there's no doubt that in the world of JSON, there are a lot of developers who live in IDEs, you know, IntelliJ or VS Code or whatever, and do not find it very comfortable to have to fish around by hand inside the JSON to figure out what they're dealing with and so on. We'll come back to that. What else? Oh, right. So this is sort of related to the JSON binary, but not intrinsically. A lot of the content of events is business data, and business data tends to live in relational databases, which means that people consider data to be constituted of flat rows of columns, with each column having, you know, a name and a data type. And the people who think about this kind of data really like to think in SQL. Alternatively, these days, a lot of data is packaged up, say, as JSON, but has deeply nested structures inside it, which may, in fact, contain repeating things, deeply nested and repeating. And these are quite different things. And the kind of tools you can use to process them is different. And I would actually encourage you to think about this one a lot if you're going to put up a new piece of event-driven software, because the cultural difference between these things is way more than you might think. If you start with rows and SQL thinking and, you know, sort of relational worldview and start shipping flat events around, and then the time comes that you realize that, oh, this thing isn't flat at all, you know, I need to put something on there that's got deeply nested repeating structures, you could be in an uncomfortable place, and your SQL tools are probably going to be unhappy with you. On the other hand, if you start up with, you know, JSON-like stuff and deeply nested events and everything's working fine, and you bring a new group on and they say, oh, we need to filter them, and of course, you know, we do everything in SQL, you just may not have a good story for them. And this is kind of a one-way door. Once you've started walking down one of these paths, you tend to be stuck on it. So do please think about it. OK. Another facet that we observe that can really change your life is whether the events are all the same or not all the same. So in the world of eventing software, there's a popular construct called an event bus, which is where the events all live, and it's a storage and delivery medium, and you subscribe and you get events off it. And lots of them have nothing but the same event, just different instances of the same type of event. And if you're dealing with one of these, your life is easier because you can just process each one with the same software and not have to think about it too much. In my experience, that is a minority case. The vast majority of event buses I see out there have lots of different heterogeneous events on them, and people seem to like that, and it seems to be useful. But of course, it does mean that as the developer, when you pick something up off the event bus, you have to figure out what is it so that you know how to deal with it correctly. And sometimes that's relatively easy, but sometimes it gets you into a position where you end up doing this kind of thing. So here's a few lines of Java that are looking at a JSON blob to figure out if it's what's called a pass node, which means it has a top-level field type whose value is the string pass. And of course, to do this in JSON, first of all, you have to find out if it's an object, so it can have fields. And then if it can have fields, you have to ascertain if it has a field called type. And then you have to look and see if type is a textual field as opposed to 33 or false. And then after all those other things, you can check and see if it's the actual value you're looking for. I've written quite a bit of this code, probably because I live down at the bottom of the stack, dealing with stuff coming over the internet. And it's not that taxing. It's not that complex. It's not hard to write. It's not hard to test. But I do not think that writing this kind of code is a good use of our time. It's tedious and boring. And this is probably the sharp, pointy bit that sort of divides API-centric thinking and event-based thinking at this point, because API-based thinking is all contract-based. And you're always dealing with strong types. And you can go and look at the list of APIs, and then once you're in your IDE, it knows all the APIs and can autocomplete everything. And this has been kind of the number one source of discomfort with developers that we've been hearing for quite a time. So we fixed it. So what we did is we announced Sunday night a schema registry so that events can be strongly typed. So you can write schemas in here if you want to. But it would be boring to launch a registry with nothing in it. So at launch, it contains pre-cooked schemas and related materials for all the events that are currently on EventBridge, all those system events, like, for example, EC2 status changed, and so on. And you're thinking, wow, that must have been a huge job, writing schemas for all those events. And it would have been, but we didn't. What we did instead was constructed some software that can look at an event stream and then construct a schema synthetically from it, infer a schema, if you will, for that, which turns out probably to be more accurate than a human being trying to write the schema. Anyhow, so if you are going to, and we did that, but it's a publicly available service. It's priced that for any sane amount of developer use, it should be free. So if you are going to start placing events into the ecosystem, I strongly encourage you to go to the service and send a few thousand of your events at it, and then use that schema. And it's a fully updatable database. So if you want to fix the schema, you don't like the way the automatic one did it, you can do that as well. What was I going to say about this? Oh, right. Obviously, we've also got the schemas for the third-party events. Oops. Go back. Right. You can also go back to the, I know what that problem is. Right, OK. You can also go back to the, it also contains the schemas for those third-party events like Zendesk that I showed you. So the service is still in preview, so there's some rough edges. For example, the tiles listing the schemas should have human-readable labels, but it's sort of decipherable anyhow. So suppose I want to write some code to process some of those EC2 instant state changed events. So let's actually run this thing. What I would do is, this thing has an Elasticsearch search index attached to it, so you can go and plow through it and find what you want. So what I would do if I were interested in EC2 instant state changes, I would just type that in, and anybody who's used a search engine, the behavior is familiar. There it is. It's the first thing. So I can go and click on that, and it'll actually show me the schema, But you know what? Schemas are boring. And nobody actually reads these things or thinks about them. I actually want to use the schema to make my IDE smarter. So what I would do is I would go download a whole bunch of code we've generated, which contains class files and serializers and that stuff for those 3 programming languages. Oh, Java, Python, and TypeScript for the people at the back. Probably C# and Go would be the next ones to come. So if I went and downloaded that, I would get a zip file containing, the class declarations and serializers and a bunch of stuff. It's also in the AWS toolkit for IDEs for IntelliJ and VS Code. But, however your dev environment is, once you've got those class files, you can just use them any old way you want. So anyhow, let's actually just switch over to IntelliJ here any minute now and see how this thing works in action. So here's IntelliJ. It's got the AWS toolkit, so the stuff's down there in the lower left. You can see all the different AWS event types that it just knows. So I can click on here and do search, once again, searching for that EC2 instance status changed. And I could download the bindings here right in the IDE, which I've already done. So let's actually use it. Let's write some code for this Lambda that's just getting a generic input. And I want to turn that into an EC2 instance state changed event. So what I'll do is now the IDE knows all about AWS events and all the different kinds of things that can be packaged up inside them. So I'm just going to make a variable called event. And one of the things that came in the code that I downloaded was a marshaller. So I'm just going to unmarshal the event. And to do that, I have to give it the input and the class that I want to unmarshal it into. Let's indent that so it's pretty. And now, here's the fun part. Now that I've got my Pojo, my Java object, I'm going to use it to extract the instance ID. And so, because we are now in strongly typed territory, look, .getDetail, .getInstanceID. It just works. And you didn't have to do any work to get there. So I think this is going to be useful for a whole bunch of people who are writing event-driven software. We're not finished yet. There's lots more work to do. Like, for example, the Java code should be in Maven, and similarly for the other things. Also, there's a SAM template for this thing. So you don't actually have to call the marshaller. It'll go and call the marshaller, and you can just have a routine. It'll call you with the right strongly typed thing. So this, as it stands, is already useful, I think, for people who are writing event-driven software. But I think it's really at the start of something considerably larger. If you look at the whole internet and the cloud in particular, and the AWS cloud in particular, you'll notice a lot of services that deal with sort of opaquely typed blobs. And I think that what we need to do is get to a position where we have a much more strongly typed cloud, optionally. Nothing wrong with blobs in certain cases. So I want us to get to a place where we have strongly typed lambdas and strongly typed kinesis streams and strongly typed SQS and strongly typed dynamo tables and so on. And now that we have a place to put the schemas and so the types have ARNs, we can actually have the foundation we can start to build on. Now I'm not going to tell you this is all going to happen in the next 3 months. Okay, there's quite a lot of work to do. But as the Tao Te Ching says, the journey of 1,000 leagues begins with a single step. So there's your single step. Let me see. I suspect, by the way, based on my experience, I suspect that Terraform and serverless.com will have support for this wired in before I get back from reInvent. So we went through all those different event facets. So what I did was I made them into a table. So across the top are some popular pieces of event-driven infrastructure. And then here are some of the facets that might be useful in choosing between them. Some of the facets aren't useful. For example, JSON versus not JSON, they can all do that. And latency is not useful because the answer in every case is it depends. But when you are sitting down to create some event-driven software, I think you need a table like this, maybe just on the whiteboard in your office or maybe in a design doc you ship around, because there's a whole lot of event-driven infrastructure out there, and it's mostly really good, but it's different. Each one brings a sort of different selection of attributes to the table, and I don't know, this is how I think about this stuff. And so maybe we should publish this particular table in a blog piece. I'm a little reluctant to do that because the target is moving, and maybe I was slightly wrong about one of these things. The point I want to make is not that this is the table, is that you should have a table. And I certainly have had some of these on the wall of my office. Okay, so I have now just spent 45 minutes telling you about event-driven software and why it's great and some of the finer points about it. So am I saying that everything is event-driven in the future? We're going to sweep everything away? Well, of course not, because APIs aren't going anywhere. And I think that neither APIs nor event-driven will wipe each other out. Now, obviously, the term API is a very broad brush that is used to describe everything from a Linux system call that takes nanoseconds to an EC2 describe instances call that can take really long time and produce a huge amount of output. But the essential thing that sort of defines an API, and the reason why sometimes it's not such a great choice, is that API thinking is sort of synchronous thinking, right? I move along, I'm doing work, I call the API, and I'm frozen until the API finishes its work and gets back to me, and I can go on doing work. And that's fine, except for if you're in a big multi-microservice system and the requests I'm getting start coming in at even 1% faster than that API can process them. We're going to be in a world of hurt very, very quickly. Now, fortunately, things are moving forward, and the dividing line between eventing and APIs is getting blurry. I mean, to start with, we've gotten smarter about HTTP. I mean, and there's a lot of developers who are smarter, who these days understand futures and promises and can think about asynchronous programming. There's also a fairly common pattern where you call a complicated HTTP endpoint, and it comes back with 201 in progress, and it gives you a URL you can pull to see what's going on. So the dividing line is growing blurry. Another pattern that is used in a lot of popular messaging APIs is the objective being to give you a request response. Because even if you don't want to be API bound, it's a reasonable thing to ask for something to be done and then get a response for it. So one good way to do this is something we've seen in a bunch of popular APIs is you send off an event, and in the event you include the identity of a queue or something that you want to get the response on. So go off and do something, asynchronous, send, receive messages, do that, and send it back to me. This is actually wired into some of the popular event brokers I mentioned earlier. It's sufficiently popular, it's already built into JMS. I think the term they use is virtual queues. Anyhow, so you can make a JMS call and then get something back on a different queue. And it's sufficiently popular, in fact, that we ship an open source library. I'll get to that in a second. We'll ship an open source library for SQS that does that. Allows you to fire off a message and in the message specify to get the answer back on a different queue. So APIs aren't going away. APIs and messaging are fundamentally sort of different ways of thinking about things, but the line is getting blurry. But neither of them is going away. Another way to deal with the temporal brittleness of APIs is the service mesh, which has been getting a lot of traction recently. Usually, when people say service mesh, they're talking about Istio, which is a Kubernetes thing with Envoy. It's pretty well joined at the hip to Kubernetes. Although recently I found out about Linkerd, which looks like a really nice thing in the same space. But anyhow, the idea is these things are like super smart proxies. So normally in a complex application with a lot of microservices, you call each other based on IP addresses or DNS names. And with a service mesh, you don't have to. You just say, call the customer info service. You don't have to know anything aside from its name. And then the event mesh gets in there and proxies it, and it can do all sorts of things. It can check to see whether that's legal. It can do load sharing across different backends. It can do metrics on quality of service and errors. It can do all sorts of stuff. And one thing it can do is get some inventing infrastructure in there so that you can have what looks like an API call to the caller that actually has some asynchronous machinery underneath. And that's probably a good option if you're dealing with locked up APIs that you don't have the source code for and don't control and so on. But so that's a good idea. But I think that if you are going to design a system consciously to be event-driven and thus more robust and flexible and so on, it's probably good to expose that so that the modules are aware of where they're sending and receiving, rather than just hiding it all behind what looks like an API. Okay, so there you go with events. I am going to conclude by pointing out why we're not done yet. So if you talk to people who do a lot of work with events, here are some of the things they complain about. So most people discover this pretty soon after getting in, but when you have events, you can have loops. You can wire up your S3 bucket to, to generate a Lambda, to generate an event whenever something is dropped in there, which you can route to a Lambda, which then calls, a batch job that then, goes and calls some other Kubernetes service, and so on and so forth. And somewhere along the line, somebody drops something back into the bucket. Oops. Now you have a loop. So we have some machinery in place to catch most of these things, not all, but our customers are insanely devious and have these 5-way trampoline loops with side effects of side effects. And I have to say, when you get the power of the cloud behind one of these things can get real ugly really fast. So at the end of the day, this is our problem to solve, but you might make your own life easier if you think about it. This is one of the classic cases where a hyper-intelligent intern can make a little mistake on a test case and cost you $200,000. I laugh, but that kind of thing actually happens. So it's also a good example of why AWS accounts having limits is a feature, not a bug. Another thing is too much pipe fitting. And what I mean by this is I'm seeing the existence out there of what I would call a lot of dumb lambdas that just rearrange the fields in an event, or just drop the event into Dynamo. Very common scenario. And OK, there's nothing wrong with that. If you need small pieces of ad hoc code, Lambda is a very good way to do that. But then you have to write the Lambda, you have to version the Lambda, you have to test the Lambda, you have to own the Lambda, you have to monitor the Lambda. And some of these things that you think of as easy aren't. I mean, consider a classical little dumb Lambda that takes an event and drops it into a Kinesis stream. Perfectly reasonable thing to want to do. Easy, right? Well, did you batch? Probably not. Did you ensure it was encrypted on the wire? Did you successfully handle throttling when Kinesis throttles you? Do you successfully handle the case when Kinesis sometimes comes up with a random 500 error? You shouldn't have to do that stuff, right? That should be our job. So obviously, to the extent that we can bring pieces of declarative built-in software to make this go away, that would be beneficial. Permissions and access is a bit of a pain point. These days, if you have, there's actually a talk at reInvent here called API 301, where they talk through what you have to do to take an app that's got an API gateway, a Lambda, an SNS topic, and 2 SQS queues, and what you have to do to make that really secure in terms of roles and IAMs and policies and VPCs and everything. And it's work. It's real work. We have all the tools and we have all the flexibility you need to get there, but we need to figure out a way to make that easier. And there's two things that can go wrong. One is, for some reason, you just can't get it to work. This Lambda won't write to that Dynamo table. Why not? And the other is, you get so mad about that, you put in a star.star in your permissions, and that's bad too. So we need to make it easier for people to get to a place where they have the minimal permissions in a correct way. And then finally, the number one point of complaint from our customers over in recent times has been the fact that the events are opaque blobs and they can't discover them and they can't autocomplete through them. But we fixed that as of Sunday, so that one's done. Now, I'm not promising to come back here next year with red lines drawn through all these things, but these are the things that we think are important. And what usually happens is, you people out there get ahead of us on figure out the right solutions, and then we just build them. So if everybody else wants to think about these things too, that would be great. So I don't think that's about all I'm going to say. I don't think, to be honest, that I really need to do that much evangelizing of the form that events are good, you should use them, because EventBridge service, we've already disclosed that there are hundreds of thousands of people using Lambdas, and the world of event-driven processing is quite a bit bigger than the world of Lambda. This is big stuff, and the single most important takeaway I'd like to leave you with is that event-driven software is not exotic, it's not corner case, it's not bleeding edge, it's not futuristic. As of 2019, it's meat and potatoes. And if you're building a substantially large, decoupled service, you probably should be doing this. And a really good time to start is now. So, more education. Thank you. Please fill out the survey.